Today's going to be 81-2, and we're going to focus again on inverse functions, and today we're going to be finding the inverse. And so we're going to find the inverse of a function. Now the reason why we spent all this time trying to find out if the function is one-to-one is because we know that the inverse is the swapping of the x's and y's, or swapping the domain and range. Now, we know that any equation that we have could have an inverse. So like if I said y equals x squared plus yx, or xy, okay, the inverse equation to this is going to be x equals y squared plus xy. Okay, all I did was just swap the x's and y's. I swapped the domain and range. But the issue is, this is not a function. Neither is this. Now, with our functions, if I know that I have some sort of function and it equals some sort of value, if this function here is one-to-one, that means that my inverse function, or at least I should say the inverse, is a function. So if it is one-to-one, then inverse is a function. And we're able to actually express it with that f to the negative 1 power there. Like, even though it's not really f to the negative 1 power, it's f inverse. That's the symbology that we do to f inverse. So if my function's one-to-one, then its inverse is a function. So that's really important. That's the reason why we spent all this time trying to find if my function is one-to-one. Now here are the steps for us to find the inverse of a one-to-one function. You basically, instead of writing it as f of x, you switch it with the y. Now because the inverse is the swapping of your x's and y's, or switching your domain and range, so you're going to interchange your x's and y's, and then you're going to solve for y. Now remember, if that function is one-to-one, then we can write it as f to the negative 1 like that, or f inverse. So find the inverse of this following one-to-one function here. So make sure we write it as y equals. So I get y equals 1 minus 2x over 5. Then interchanging my x and y's, so actually applying the concept of the inverse. So interchanging my x's and y's. And now I want to solve for y, get y by itself. And so I'll start it over here. So this process of getting y by itself, you'd multiply both sides by 5. So then I get 5x equals 1 minus 2y, minus 1 on both sides, and divide both sides by negative 2. Now, this is a one-to-one function. Okay, it's established in the beginning that it's already a one-to-one function. Now because of that, I can write it as my inverse of my f function is 5x minus 1 over negative 2. You know, you could also write this as, negative 5x plus 1 over 2. So that's another way that you could have written it if you distributed the negative through. But that's our purpose. So the first thing that I did was make sure it's y equals, so I swapped the f of x with the y. Then I interchanged my x's and y's here, so I swapped my x's and y's, okay, in this process right here. So f of x as y, then swap the x and y. And then step 3, we have to solve for y. We got to get this y by itself, and so this is the process in which I got y by itself. Once y is by itself, you can write it as that f inverse notation. Now that's essentially the inverse. Now it does get a little bit more complicated, not in concept, just in algebra. So on this next one here, this 2x over 1 minus x, to be able to find the inverse for this, it's y equals. Okay, interchange my x's and y's, so I get x equals 2y over 1 minus y. And now I need to solve for y. Well, I have y in the denominator, so we have to get it out of the denominator first. So I'm going to multiply both sides by 1 minus y. So now if I do that, I get 1 minus y times x equals 2y, because they cancel out there. Now I have x's and y's. Okay, we said we want to get y by itself, so maybe distributing this through. So I'm going to get x minus yx equals 2y. Now I want to get my y on the other side, so I'm going to add yx to both sides. So I'm going to get x equals 2y plus yx. Now there's a y in common, so let's factor out the y. And now I can get y by itself by dividing both sides by the 2 plus x. So now that it's y equals x over 2 plus x, writing it as my inverse, there's my answer. Now remember, for me to be able to use this notation here, my original function has to be 1 to 1, but I'm telling you, I'm letting you know that my functions originally are 1 to 1. Now finding the inverse of this function here. So we said we write it as y equals. Now interchanging my x and y's. Now solving for y, I have to take the square root. So I'm going to get plus or minus the square root of x equals my y. Now this is not a one-to-one function. So because this is not a one-to-one function, I cannot use my f inverse notation at all. Okay, because it's not a one-to-one function, I cannot use my f inverse notation. So even though that this right here is my inverse equation, I found what the inverse is, I cannot state that being an inverse function because it wasn't originally one-to-one. Now to be able to use my inverse notation, I have to limit my domain from my original problem. So if this was my original graph here, I'm going to write it a little neater than that. If this was my original graph here, if I limit my domain, let's say to this part right here, and I limit my domain there, that means now this is going to be the part that's going to be graphed. And so then only this half I can write it as that function. So I could say my inverse function is only the positive square root x, or my inverse function is going to be only the negative part. It can't be both, because if I do both, I get that, and it fails the vertical line test. It's not a function. So just to be aware of that. Now, what are some of the concepts that were discussed today? I want you guys to think about that. What switches when finding the inverse, and how do you exactly find the inverse? Now, what I want you guys to do is I want you guys to go ahead and answer 1, 2, or 3 of these questions in the comment section, and I want you guys to comment on each other's posts, and I will as well give feedback on these. Okay? But just remember, the concept that we did focus on today is the inverse function. So if you guys do have any other questions about anything that was discussed in this lesson, do not hesitate to ask and leave them in the comments.